Network communication. In this module, we will introduce the initial components of network communication. We review what takes place when you communicate within a network. So what we're going to cover in this section is we're going to categorize the client-to-server communication. That is, how do clients and servers communicate at the network level? Once we've done this, we're going to look at the domain name server. Domain name server takes the human readable form and prepares it for the machine. Then we're going to look at the address resolution protocol. This is how we take our information and we apply it within the network. So client-server communication. Clients use ports greater than 1023 in most cases. We consider these transient in nature, and this is because as clients, we do not spend much time in a connection. Therefore, it's transient, or another name for that is ephemeral. Think about how when you connect to a page on the internet, how much time do you spend before you click on something else? That's why we traditionally use client-side traffic as transient or ephemeral. Servers typically operate in the lower than the 1023 port range. This is what we call reserved or privileged ports. That's because you used to have reserved privileged permissions to be able to access them. So what this does is it's an open state and it just waits for connections. That is, it's a door that's open on the machine. This makes it much easier for an attacker since they know the server is there to serve up services. That means it's always going to be there and available for an attacker. That's why most of the time, the majority of the attacks are against servers, or as you'll learn nowadays against mobile devices because people use them like a computer. So the domain name server, when you type in that name, it maps that name to an IP address. This is because the computer wants to draw the raw data of binary ones and zeros. It does not care what the actual readable name is or if a human can read it or not. Remember, all computers do everything in binary. They want that IP address in ones and zeros. This is the language of the machine. Everything is in binary. To it, it doesn't matter what it looks like other than ones and zeros. Traditional IP address we see is represented by 4 decimal numbers. This is what we call dotted octet. That's because it's 8 bits of binary for each number. This example here we show is how humans typically view an address. It's 192.168.0.128. That's what it looks like to a human. This is what it looks like to the computer. This is 8 bits of binary for each number. As you see, the computer doesn't care about if we can read it or not. So when you look at those binary numbers, the ones and the zeros, it makes it a challenge to read. So for our purposes, we like to use hexadecimal representation of this. And this is the IP address in hexadecimal. That is, it's C0A80080. This is how, when we start doing our protocol analysis, we want you to look at it. We want you to always look at things as if it's in hexadecimal, which moreover is binary, but we're not going to task you with trying to learn all those ones and zeros. It's much easier to look at 2 digits in hexadecimal, which represents 8 digits in binary. So this is easier. Some might be saying it is not, but trust us, once you practice, you'll be able to convert between the decimal and the hexadecimal as easy as writing your name. Now we come to address resolution protocol. Now, address resolution protocol is how we map the actual IP address. This is the main protocol for getting the data into the machine. The IP address just gets the data to the network. That is, it gets it to the data or the wide area network device, usually in the form of a router, that belongs to that local subnet. We need the MAC or the physical address to send the data into the machine. And this is how we use ARP. The address resolution protocol gives us that physical address to send the data into the machine. In this section, we've defined client-server communication. That is how clients and servers communicate. We have explored DNS and how it maps the name to an IP address. Remember, computers only care about binary, ones and zeros. They don't care about the numbers or in a human readable form. We enhanced our skills with information on ARP, the address resolution protocol. Remember, ARP is what we use to get us the physical address. And the physical address, or that MAC, that media access control address, that is the required address to get the data to the machine. Next up, we will explore these protocols and you'll get to look at the file 1 static packet capture file.